Alright guys, so in this video we will be going over deployment of Spring Boot application, or let's say any kind of microservice. You can replace Spring Boot with Python, Node.js, in whichever environment you are familiar with. We will be deploying that application in the Kubernetes, which is hosted by AWS and which is known as EKS. So if you have gone through my earlier videos, right, where I have deployed multiple services into Azure Kubernetes Service, in AWS we have Elastic Kubernetes Service, EKS. All right. Concept is same. If you are aware about Kubernetes concept, everything is same. It's just that AWS has a different Kubernetes service which is known as EKS. So in today, as part of this video, as part of this exercise, we will be deploying an application which is developed in Java, which is kind of a Spring Boot application, and using Helm we will be deploying this application into EKS. The way we will be deploying is using CI/CD, and CI/CD will be based on whatever AWS provides as part of CI/CD tools, which is code pipeline, and in the code pipeline we will be using code build. So this is kind of a discussion whatever we will be discussing today. So let's go through this diagram and understand the components and subsystems of this overall workflow. All right, so let's understand this part first, the below part. So we have developer here, right, and then we have our GitHub repository here. So developer will make a commit to the developer to GitHub repository. So that GitHub repository has, the code base has, it's a Java code base. It also has the Helm charts for deployment. It also has a Docker file for creating a Docker image and deploying as a Docker container. And it also has appsec.yml. So you might be familiar with Java, Helm and Docker file, might not be familiar with appsec.yml. This is something that we will be deep dive into some time. Let's move over. Hold on appsec.yml for some time. So we have then this guy. So this is your build pipeline. So the build pipeline today you create in AWS is using code pipeline. All right. So code pipeline is made up of multiple components. Code commit, code artifact, code build, code deploy. All right. As part of this exercise, we don't need code source, code commit, and code artifact because we're not using AWS hosted repository management system. We're using GitHub. So we already have our source repo here. This source code repo, change in the source code repo will trigger a build in the code build. So code build is something that basically takes care of the build part of the code pipeline. All right, and then you have code deploy, but in EKS from 2022, AWS has restricted the usage of code deploy to deploy your workloads into EKS. However, it does support, I think, Fargate and deployment in AWS Fargate, and it does support in EC2, etc. Yeah, but it does not support EKS anymore after 2022. All right, so so this is kind of a build pipeline, and once your code build will be done, so how code build will work? Code build will look for a file which is appsec.yml. So let's understand. If in the other videos I explained you the Azure DevOps pipeline, where I explained, okay, whenever you create a Azure DevOps pipeline and you linked it with the Azure DevOps pipeline, you create a file, it automatically creates a file Azure-pipelines.yml, right? In the same way, AWS has a different naming convention, which is appsec.yml. So so the question is, how will your code build will understand that these are the certain steps I have to run whenever this build will be triggered, right? So these steps are defined as part of the appsec.yml, and very soon we will deep dive into all the steps and the indications of those steps and how can we make changes and alters as per our need. All right, now let's move over, and this wheel is the indication of Helm. Since we will be using Helm to deploy everything into Kubernetes, so that's the indication of Helm. Now we have this ECR. ECR is Elastic Container Registry in AWS, same way that we have ACR in Azure Container Registry. So when you will be creating Docker images as part of your code build, those Docker images will be pushed to your ECR here. All right, so maybe I can move this arrow to here. All right, because you see here. All right, so yeah, okay. Now ECR is your container repository. The same way you have ACR and the same way you have Docker Hub, right? So it's the AWS is hosted specifically ECR container registry. So your all Docker images will go to ECR. Now, this guy is your VPC, virtual private cloud. Now, what is VPC? You already know, if you are familiar with Azure cloud, then you might have heard of Azure Virtual Network, VNet. And same thing in the AWS is known as VPC, virtual private cloud. So it's your isolated place where your resources are connected in a logical network. So it's the VPC. All right, and all those concepts are same. The concept of network security group, which is in Azure, but here you call it application security group, and the concept of subnets, the concept of public subnet and private subnet, every single thing is same. Then you move on, and then you see this blue box. This guy is your EKS, Elastic Kubernetes Service, right? So this is your Kubernetes cluster hosted in AWS. Okay, and these are your workloads that we will be deploying as part of your code pipeline, right? So the now understand, as part of your build pipeline, which is mentioned here, right? This part, this whole part, you will be creating a Gradle build, creating the jar file using Gradle build. Using that jar file, you will be creating a Docker image using your Docker file. Okay. Using your Docker file, when you will create a Docker image, you will be pushing it to the ECR, your Elastic Container Registry. Then using Helm, you will be deploying the Docker image which is in the Elastic Container Registry to your Kubernetes service. So that's the whole flow we will be doing as part of this exercise. Okay. So there are two parts of this video. One part is we will be discussing about this upper part, this part, all right, this part, and then second part we will be discussing about this part. Okay, so I'll be recording two separate videos, one to explain upper part, second to explain below part. All right. So now I have already theoretically explained you. Let's go to our AWS cloud and understand and have a look and feel to ECR and how can we provision it, and if there is any important component to understand. Okay, so I'll go to my ECR. I'll go to and if I search ECR, you will see. Okay, I have this ECR, right? How can I access this ECR? Using this URI, right? This is the way to access this particular ECR. If I go inside it, this is the name of ECR. You see there are already many images exist. Okay, now if I want to push something to this ECR, what will be the commands? So if I click view push commands, you will see this command you can use to log in into ECR and push something to your ECR, Docker build, Docker tag, and Docker push. So why I'm discussing about this? Because very soon we will be using all these commands in our build spec.yml file. All right, so this is your ECR. Now have a look to your VPC. I have two different VPC here configured, I believe so. I'll go to VPC. Alright, so I have two VPCs. So this is my project VPC. In this VPC, I have deployed my Kubernetes service. Alright, so you see, in my VPC, I have these subnets, right, available. So subnet is basically logical separation of the entire VNet in terms of addresses, in terms of IP addresses. Okay, so you can use as public subnet, you can use a private subnet. All the resources within a subnet can talk to each other properly. And if you have network policy which does not allow to talk one resource in one subnet to another, so that won't happen. So all those things of related to VPC virtual network, you can play around in the as part of the VPC or virtual network. Okay, Then there are many components, right? Internet gateway, and then you have route tables, and then you have NAT gateways, which I will be creating another separate videos of deployment of EC2. There we will see how internet gateway is used to get the internet connectivity to your EC2 instance, and also we will talking about NAT gateways. How can we get the internet access using NAT gateways into EC2 instance, which is deployed in private subnet. So that's the concept of all internet gateways and route table subnet. I'm only talking about because the major focus area of this video is to deploy application EKS, not to discuss deep dive into VPC. I'm just giving you a look and feel, right? And then we have our important guy EKS, right? So if you go to EKS, you'll see EKS. Elastic Kubernetes Service. Okay, so I don't see any cluster because that cluster presents in US West 2 region. I'll switch over to you see this is my cluster. So this is the EKS cluster that I have already created. You can create one. It's very simple. You will find the documents in AWS and anything. All right. Yeah, it's a very important point is in AWS, whenever you create something, you will also have to create a role to assign it, right? So using that role, so for example, you created a EKS service, and then using that EKS service, you will have to assign a role to your EKS. So based on your role, there will be some policies assigned to that particular role. So now let's say your EKS want to use S3, but the role that you have created for EKS doesn't have the policy which allowed doing things on S3. So your EKS won't be able to access your S3, right? So that's how the whole IAM system works in AWS. I'll go to that. I'll go to that point. I'll duplicate it, and then resources, roles, no roles, cluster, nodes, and then I'll go to IAM. If I go to IAM, okay, I already have it here. Okay, so I'll see in the IAM I have one user. Now I'll tell you what user it is, and then you have these many roles in it, right? You have these many roles in it, right? There are like EKS cluster role, EKS code build Kubernetes role. There are multiple roles, right? And then this is a different role. I'll talk about this as well. Let's talk about this user. You see, this is my user that I have created to access my Kubernetes service into my local computer, right? So, and how can I access that? Using my access key. You don't have to use your password. Once you create a user into IAM, you can simply create some access keys. Using those access keys, you can configure your AWS into your local computer and access all those resources. Okay. Now to my user, what are policies I have assigned? You see, I have assigned that to this user you give administrator access, to this user you give all EKS access. Although if I'm using this administrator access, I think I have access to everything. I don't have to use these policies, right? And then just for understanding, let's see. There is another policy assigned which is change user, right? There is another policy assigned which is all those things: create network, describe subnet, etc., etc. So your policies govern what all things a persona, a user, or a role could do, could not do. So this is the concept of IAM, and it's very amazing in AWS what I see comparatively to Azure. All right, so let's move on and let's have a look at the roles. If you see, there are multiple roles. For example, if you go to this role, this is the role which is being used by code build, right? Which is used by this guy. Now, there are two things. There are some resources. For example, when you create a code build, when you provision a code build will automatically create a role for you, right? For example, right here, you see right here, it has automatically created a role for me and assigned some important policies to automatically to it, right? AWS will do it for you, or you can add on some policies if you want so, right? For example, I've given this user full access to S3, right? And I've given this user administrator access, which is incorrect. You should not do it, right? And then I have given this EKS cluster policy, right? All those things. So this is what I have, all these policies I have given to this particular role. So all these things this particular role can do, cannot do, this basically get decided based upon the role or the policies you have. All right, so let's move on. Let's not go much deeper inside. So I'll make a different video on role and policy if you want. So you can comment, and if you comment, I'll create one video. Okay. Now have a look at EKS. So this is resource part, which is not much important. You can just play around it anytime. If once you provision, you can get 1 year free subscription in AWS. You can play around EKS. Now look at the compute part. So I don't know if you have gone through my earlier videos where I have spoken about Azure Kubernetes service. Good part is, so let's compare to the other Kubernetes. You will get an idea. When you create a Kubernetes service in your Azure cloud automatically will provision a VM skill set in the background on which your Kubernetes service will work. So the way it will work is your Kubernetes service will create all the nodes and everything over to that VM skill set which is running. What is VM skill set? It's kind of a elastic VM where scale up and scale down can be done automatically. We don't have to do a manual intervention in order to do that, right? Same way, when you provision an EKS in the AWS cloud, it automatically provisions a auto scaling group in your AWS. All right. So what is your auto scaling group? The same way you have Azure VMs, the same way you have AWS EC2 instance, which is virtual machines in AWS. Now the elastic version of your EC2 instance is known as auto scaling group. So the scaling of scaling up and down happens automatically. So those are the auto scaling group. So you see the node group that it has created. If you go to this group name, I'll go to group name EC. Right. So this is the auto scaling group. So if you go here. Okay, auto scaling group. Yeah, you see auto scaling groups. So here, this is the auto scaling group it has created when I was provisioning the Kubernetes service. All right, you can create one auto scaling group if you want me. So you don't have to use many organizations. What they do is they will create auto scaling group, does something on it, provide some energy, etc., and then assign it to the EKS service. All right, so that's the way it works. And then in the instances, you will see the instances running on it. So I'll make a separate video in EC2 instances to understand many things, many components of VPC, Internet Gateway, Net Gateway, whatever I spoke some time back. All right. So let's go back to your Elastic Kubernetes service. So that was the basic concept of Elastic Kubernetes service. All right. Now, I don't know. Okay. So you can create one. This is one thing, or you can use EKS CTL. You will have to install it in your local computer, or you can use AWS CLI commands in order to provision one cluster here. Concept is same. You will have a private cluster, you will have a public cluster, you will have a private and public cluster in the AWS. So the way it works is in private cluster you can only access your cluster around the VNet, right? Not outside the VNet. When I say VNet means VPC. And the public Kubernetes you can access from outside, and the public and the combination of private is your worker node will be inside the private, and your controller node will be on the public side. So that's the combination of private and public. All right. I will not create one. It's very simple. You can just go to any AWS document. You will find the step. Just follow it blindly. You will able to, and you will end up creating one cluster decently. All right. So now okay. So we discussed about all these things. So this is IAM. We already spoke about it, right? So we already talked about this subsystem. Let's talk about this subsystem. Okay.